Hello students. In a previous lecture, we have discussed inductive effect and its effect on the acidity. So in today's lecture, we are going to discuss about the effect of mesomeric effect on the acidity. So as we know that there are two types of mesomeric effect. One is positive and another is a negative mesomeric effect. So positive mesomeric effect most commonly denoted as plus M or plus R. So which are the groups responsible for exerting positive mesomeric effect? They are OH, OR, SH, SR, NH2 and NR2. So friends, which groups are responsible for negative mesomeric effect or minus M or minus R effect? They are NO2, carbonyl, nitrile, COH and SO3H and so on. So these two types of mesomeric effect have high impact on our acidity. So let's see how this plus M or minus M will affect the acidity of compounds. So first is a minus R or minus M effect. So you can see here the we have two example. One is para-nitro-benzoic acid and another is a benzoic acid. So as you know that acidity is depend on two factors. First is availability of uh, H plus ion in the solution and stability of conjugate base. So among these two, tell me which one will be the more acidic. As you can see here, para-nitro group is going to exert minus R effect and it is going to stabilize our conjugate base which is found over here. But in the benzoic acid there is no such kind of minus R or minus M effect group. Okay, so it's very easy. Para-nitro benzoic acid will be the more acidic than the benzoic acid. You can see here, this is the stability of our conjugate base. So what is the takeaway from this slide? Minus R or minus M effect increases acidity by stabilizing conjugate base. So you must remember this sentence, that is a minus R or minus M effect increases acidity by stabilizing conjugate base. Now friends, I have a few example for you. So this is a plus R or plus M effect. So best example over here, para-methoxybenzoic acid. So this methoxy group is going to exert the plus M effect. So what this plus M effect will do? It will destabilize our conjugate base because this is a negative charge and again this is providing electron density. So our conjugate base is destabilized and hence it will recombine with your H plus and the availability of H plus in the solution will be very less and the compound is ultimately going to be the less acidic compound. So I have a question for you guys. Okay, I have A, B, C, D, and E. These are the five examples in front of you. So, this is a benzoic acid. There is no substitution over here, but I have some example in which we have plus M effect and minus M effect. So, OCH3 will exert plus M effect and decreases the acidity, whereas para-nitro, that is nitro group, will exert minus M effect and increase the acidity. So benzoic acid will be somewhere here in between nitro and methoxy because these two are less acidic than benzoic acid, whereas para-nitro benzoic acid will be more acidic than the benzoic acid. Now friends, this is another example in which we have OH group over here. So most of the time student confuse and quickly answer the question because they overlook the OH and COH. So friends, even though there are two nitro groups, this one nitro group is increasing the acidity of this COH group. Okay, why? Because phenols are weak acid than acids. So acids are always acidic than the phenols. So don't overlook this OH and COH. This COH will be more acidic than the OH group. Okay, so I have another example for you. Okay, So in this we are going to discuss about the magnitude of mesomeric effect. What is magnitude of mesomeric effect? That means these two nitro group both are exerting minus R or minus M effect. So how we can judge these two example? Which one will be the more acidic? So you can see here the minus M or conjugate base is more strongly stabilized by paranitro group than the metanitro group, because it is going to delocalize the conjugate base or negative charge in five different types of canonical structures. So for the meta we have one, two, three, four, whereas for para we have one, two, three, four, five canonical structures. So our conjugate base is very well stabilized by the paranitro, so it have more magnitude, more power than metanitro. So para-nitrobenzoic acid is a more acidic than metanitro. Okay. Now this is very important slide for you guys. This slide contains acids, phenols, and neutrals. So all these compound have OH, OH, and OH. But these three OH have different types of functional group. Okay. First is acid, COOH. Another is AROH, that is phenol, and third is alcohol, that is the neutral. So as I already mentioned in the previous slide, acids are always stronger acid than the phenols. Phenols are weak acids because this conjugate base is very well stabilized by this carbonyl group, whereas in the phenols the conjugate base is not very well stabilized like this kind of conjugation. So in alcohols there is no stability of there is no stability for our conjugate base, hence alcohols are neutral or least acidic among these three types of functional group. Okay, now this is very important example from the set 2019, and this is a very tricky example because when we start to solve this example, we go for benzoic acid, uh, paramethyl benzoic acid, then nitro, and hence we just look over here, we miss the OH over here. Friends, these two are acids and this one is phenol. So even it contains nitro group, these two acids are always more acidic than the phenol. And last is neutral compound. So how we can solve this problem? So you can see here these two are always acidic than phenol and neutral. So we will compare the acidity of these two compounds. So one is with methyl group and one is unsubstituted. So methyl group is exerting plus M or plus I effect. So it is going to decrease the stability of conjugate base. Hence benzoic acid will be more acidic than this para methyl benzoic acid. Okay, so one is more acidic and fourth one is least acidic, that is a neutral compound. So in which example we see this? This is the example in which we have one is more acidic and four is least acidic. Okay, no other example have same kind of pattern. So among third and second and third, second will be more acidic, as you can see here second is more acidic, and after that third and fourth. So right answer for this question is option number A. I have another example for you guys. This is from set 2018, and similar trick they have used to confuse you guys. So we have two phenols, one acid and one alcohol. Okay, although the substituent are different, methoxy, nitro, C and NO2. So we these are the secondary things, but primary things are OH, COH and alcohol. So you can see here this is the benzyl alcohol, and which will be the least acidic among these for example. Okay, so least. Okay, so all three options are okay, but we need to discuss now remaining three examples. So As you can see here, OH phenols. So third will be always acidic than the these two phenols. So in which example we have third more. So we have 3 is the highest over here and 3 is highest over here. So now we have option number A and D. We need to choose between A and D. So now in between paramethoxyphenol and paranitrophenol, which one will be the more acidic? Second will be the more acidic. So you can see here, second will be the more acidic and then first. So not A but option number D is a right answer for our question. So these type of questions are asked in the CSIR net, whereas MS set examination. So you need to prepare for this kind of examination and just not the para-nitrobenzoic acid and benzoic. This kind of examples are not going to help you to crack the set examination. So this is all about today's lecture. If you guys have any doubt, feel free to ask me. Thank you.